In this video, we'll be using factoring techniques to find the zeros of the polynomials. When factoring a polynomial, we look for factors common to every term and then use the distributive law. It's a standard practice to factor out the largest or greatest common factor possible. So let's look at the exercises where we'll need to write an equivalent expression by factoring out the greatest common factor. You'll also hear this referred to as GCF. We have 2t to the third plus 8t squared. That has a common factor of 2t squared. If I factor that out, I'm left with t and 4. Now notice that these are not equations, so we are not actually finding the zeros. This is just practicing the factoring portion. Let's look at B. We have a 4, an x, and a y, so I'm going to factor out a 4xy out of both terms. That will leave me with an x in the first term and a negative 3y in the second term. Now let's look at 5x squared minus 5x plus 15. All three terms have a 5 in common, so I'll factor the 5 out and I'll be left with x squared minus x plus 3. You can always check your work by distributing the 5 back in to see if you actually come up with what you started with. Now let's look at negative 6x squared plus 30x minus 48. All three terms have a 6 in common, and let's go ahead and also factor out that negative. This will give me an x squared minus 5x minus, it's not a minus, it's a plus. 6 times 8 gives me 48. So if I were to multiply that negative 6 back to the 8, that would be a negative 48. So I know that I've found the right number. This next one looks a little scary, but trust me, it's not bad at all. It's actually one of the easiest ones we have here. b minus 5 is common and is multiplied to an a and also to a c. That means that we can use that b minus 5 as our common factor. So I'm going to write b minus 5 out front. And then what would happen if I were to leave the a and the c inside? Well, all that's saying is that if you were to take b minus 5 and distribute it back to the a and distribute it back to the c, you'd be right back where you started. So you're good to go. Let's try this again. Only this time we have a squared times x minus y plus 5 times y minus x. These look very similar, but not quite the same. So let's take a factor of negative 1 out. If we were to take a negative 1 out of y minus x, that would give us negative y plus x, and that looks a heck of a lot like the first factor. So I'm just going to rearrange it. We have a squared times x minus y minus 5, because 5 times negative 1 will give me a minus 5. And rearranging the order of my terms inside parentheses, we'll have x minus y. And then it looks like it should. And now I can be confident that the two binomials match. I can factor it out front. And I'm left with a squared minus 5. And the x minus y is out front. If I look at 9, 12, and 15, they all have a 3 in common. X to the third, x to the fourth, and x to the second. We would take the lowest power of x out. So x squared is our lowest power of x. Y to the 6th, y to the 4th, and y to the 5th. So we know that there are 4 y's in common to all 3 terms. And then z to the 2nd, z to the 4th, and z to the 3rd. So z to the 2nd is common to all 3 terms. Now I have to think about what's left over. 9 divided by 3 is 3. X to the 3rd divided by x to the 2nd is x. Y to the 6th divided by y to the 4th is y to the 2nd. Z to the 2nd divided by z to the 2nd is just 1, so that one's divided out. Negative 12 divided by 3 is negative 4, and we just keep this process going. X to the 4th divided by x to the 2nd is x to the 2nd. I'm running out of room. Y to the 4th divided by y to the 4th is 1. Z to the 4th divided by z to the 2nd is z to the 2nd. 15 divided by 3 is 5, and it's positive. X to the 2nd divided by x to the 2nd is 1. Y to the 5th divided by y to the 4th is y to the 1st. Z to the 3rd divided by z to the 2nd is just z. And those are my terms left inside the parentheses. 5x squared times x minus 6 plus 2 times 6 minus x has a very similar pattern to example G above. We have to change the order of the terms and their signs. So we're going to factor out a negative 1, and that will give us x minus 6. If I rewrite this, I have 5x squared times x minus 6 minus 2 times x minus 6. And now we have 2 binomial factors that match, and we can bring that out front, x minus 6, and we're left with the other pieces of the terms, the 2 terms, 5x squared minus 2. So the fact that we have x to the 3a in here means that our x's are all to the power of a, and something's happened where those bases have been multiplied together, which means we can add the exponents. This process means that I probably have an x to the a as my common factor. I also can see that I have a common factor of 2. So I'll start there. I'll factor out a 2 and an x to the a. When I think about this, I have to remember that when I multiply bases, I add exponents. So when I'm factoring something out, it's like dividing. So that's the opposite of adding, which would be subtracting exponents. And so I have x to the 2a left over, plus 4 minus 2 x to the a. Now you can double check this by distributing that 2x to the a back in.